Okay, so this is going to be the first video for day 7 of Algebra 2, Unit 3. And in this video, we're going to talk about very briefly how sigma notation works. So, surely you've seen this before, um, just around on posters or even in movies, anytime they bring up advanced mathematics. This symbol right here has become synonymous with advanced mathematics. And what it is, it's the Greek letter. It's a capital Greek letter, sigma. So you've got lowercase sigma that looks kind of like a cursive O, and then you have uppercase sigma, which looks like just a giant E thing, right? So anyway, sigma notation in math is used as a shorthand for adding a whole bunch of different things together that follow some kind of a sequential pattern, right? And the way that it works, this first number down here, k, is basically where you start, right? This other number on top, the n, is basically where you end. Okay, and right here, this is known as the index, and basically it's just the formula that you follow. Okay, so we've got an expression here, um, the sigma of, or the sum of n times x to the k. And of course, we're referring to this k and this n, right? So what that would mean is um, we start at 0, right? And we end at whatever n is. So let's just say n was 3. Okay, so I'm going to rewrite that. Let's just say 3 k equals 0, 3 times x to the k. So k is going to alternate. Okay, so I start at 0. So I'm going to say 3 times x to the 0 plus, and I move on to my next term. 3 times x to the, so 0, then we say 1, 2, 3, and so on. Okay, and that's another thing that I should note. N and k, n and k are both natural numbers, right? They're only going to be 0, 1, 2, 3, 4, and so on. Okay, they're not going to be decimals or anything crazy like that. Okay, so we keep going, times x to the 1, plus 3 times x to the 2, and we keep going until we stop at our stopping point, which is n, so 3 times x to the third. Okay, and we would add all of these up, and of course we can't because none of these are like terms, but you get the idea, right? So let's look at a more concrete example, right? So we're going to start at k is 1, end at n is 5. Okay, so we're going to say 4 times, when we start at 1, plus 4 times 2, plus 4 times 3, plus 4 times 4, plus 4 times 5. And then we just do the math. So this is 4 plus 8 plus 12 plus 16 plus 20, right? So 12 and 12, that gives me 24, right? Plus 16, that would be 40. Plus 20, that gives me 60. Okay, so this sum is 60, right? And again, this is just a shorthand of saying that. Okay, last example for this video. So we're going to calculate this sum. This one's going to be a little bit uglier just because we have this negative here, right? But nothing really changes. So starting at 0, ending at 3. So we're going to say negative 2 to the 0 plus negative 2 to the brain fart 1 plus negative 2 to the second power plus negative 2 to the third power. Right? So anything to the 0 power is always just a positive 1. Plus negative 2 to the first power, well, that's just negative 2. Plus negative 2 squared, well, that's just positive 4. And this guy here is going to be negative 8. Okay, then we just add. So 1 minus 2 is negative 1. Plus 4 is positive 3. minus 8 is negative 5. So the sum of this would be negative 5. So that's a really, really, really basic representation of how sigma notation works. Again, all it is a shorthand for adding things that follow some kind of a sequential pattern. You'll learn a lot more about this when you get into Calculus 2 and 3, especially Calculus 2. Okay, so if you have any questions about sigma notation, please let me know. You know where to find me or send me an email. Goodbye.